last week, and I wanted to take a look at one now. So we talked about two different options. One way, just straight from the x, y, and r definition. We also talked about it in terms of drawing a triangle. So I'll work this one both ways, again, to illustrate that. The triangle is usually easier for people. However, the x, y, and r definition we have to have because there are cases where you can't draw a triangle. We talked about if it lands on an x or y axis, the triangle is impossible. So you have to have this other definition. So what you need to, if you're drawing this example down, we know it's an angle theta going through the point 8, negative 6. That's really the important piece. If I'm going to use my x, y, and r definition, I need to know what those three variables are. What is the x value? 8. Just the x value of the ordered pair. The y then would be negative 6. And remember, we can find r by doing Pythagorean theorem. X squared plus y squared equals r squared. X and y can be negative numbers, r cannot. So my r here is just positive 10. You don't have to get nice numbers. If it were like a 200, I would expect you to break it into 10 radical 2. If it has a radical, don't give me a decimal, keep it in radical form. Just write your radical in those terms. Okay, so now the 6 trig functions. So remember, we do the 3-letter abbreviation. So sine, we put the theta for the angle. What was the definition for sine? Y over r. Okay, so my y value is negative 6. R is 10. I asked you to keep it in fraction form, but do reduce it to lowest terms. So negative 3/5. Cosine theta is x over r. So 8 over 10 reduces to 4/5. Tangent of theta, the definition of tangent is y over x. So negative 6 over 8, which reduces to negative 3/4. Once you have these three, the others are just reciprocals. The reciprocal for sine is the secant, CSC, and that would be negative 5 over 3. You can just flip the final answer. Reciprocal for cosine is secant, SEC. So cosine was 4/5, so secant would be 5/4. Reciprocal for tangent is cotangent. So negative 3/4. If you flip that, you get negative 4/3. So if you have the first three, you get the second three just by flipping them. Questions there? I was going to show you how to do this one with the triangle as well. We know that they're going to come out to be the same, but I just want to kind of illustrate that for you. So it's up to you. You don't necessarily have to write this down. It's just another approach for doing the problem. If you are going to do this, if you're plotting the point 8, negative 6, what quadrant would that end in? Positive 8. Negative 6. Where it goes 1, 2, 3, 4. So this is in quadrant 4. When we draw our triangles, we always draw them so they're attached to the x-axis. So in this one, my horizontal side, what's the length of this side right here? 8. This one would be negative 6 because you went down. Do the Pythagorean theorem again to get your 10. And then we talked about SOHCAHTOA as a trick. Sine is opposite over hypotenuse. So from your angle, the opposite side is negative 6. The hypotenuse is across from the right angle, that's 10. And we get the negative 3. Cosine adjacent over hypotenuse. So adjacent means touching. 8 over 10 is 4/5. TOA, tangent opposite over adjacent, so negative 6 over 8. Negative 3/4. So you get the same answer, it's just a different way of thinking about it. Questions? So I have a question for you. Will the values of the trig functions change depending on the point chosen on the terminal side? What I mean by that, if I draw an angle, we know it's in the standard position, so the vertex is the origin, the initial side is the positive x-axis. Let's say I'm talking about this angle. I'm asking, does it matter if I pick this point or this point? No. If you think about it in terms of the triangles, if I pick this one, my triangle would look like that. If I pick this one, my triangle is like this. How are those triangles related? What are those called? Similar triangles. And we know in similar triangles, the ratios are proportional. So because in the trig functions you divide two sides, it doesn't matter whether you divide two sides in the small triangle or in a bigger one, you're going to get the same thing. Okay, so we could really take any ordered pair on this line, and it would reduce to the same trig function values. All right, so let's do one where I don't give you the ordered pairs, and you have to pick a point. So if you're jotting this down, you want the values of the 6 trig functions if the terminal side of theta is defined by this required. Alright, so we have to figure out where to begin. We can draw this if we want. Do you guys have a preference? Do you like the triangle or the X, Y, and R? Do you have a preference so far? X, Y, and R, we're okay with that. So if I just do that for the next few examples, I'm not going to lose anybody. If you need me to draw a triangle at any time, just tell me. I'll be happy to do that. In order for that to work, I need an X value, a Y value, and an R value. I can pick any X and Y I want as long as it will meet these requirements. It has to, 3x minus 2y has to equal 0, and this has to be less than 0. So let's start with x. Give me an x value that's less than 0. Negative 1. Then, I've met this requirement. You can plug it into your equation to find your y. And I get the y value to be negative 3x. We talked about how it doesn't matter what points you pick on the line. So this one is fine, but you could certainly pick a different x value. Is there anything about this that you don't like? The fraction. Is there a way we could avoid the fraction? What would you do if you didn't want a fraction? Pick a different x. What kind of x do you think would not give us a fraction? Negative 2 would work out okay. So we can keep this, or we can switch our x to a negative 2. What do you guys want to do? You want to go, you really despise fractions, don't you? Okay, we'll go with a -2 then. But you don't have to, just keep that in mind. You can most certainly deal with a fraction. So if you make your x a -2, then I get my y to be a -3. Okay, that's nice and pretty. So then could we find r? Pythagorean theorem, x squared plus y squared equals r squared. So we get 4 plus 9 equals r squared. So r squared is 13. That means r, I'm just going to leave it in radical form, the square root of 13. If you avoid fractions, it'll make your r a lot prettier as well. We can certainly deal with it, but if we got in a fraction here, you would need to do square root of top and bottom and get your radical off the bottom for your r. Okay, so 6 trig functions. I expect you to put sine, and don't forget your theta symbol. Definition of sine, y over r. So -3 over radical 13. What's wrong with that? Okay, don't leave a radical on the bottom. So we're going to multiply by radical 13 on top and bottom. So we get -3 radical 13 over 13 for our sine. Again, we don't want decimals. Just keep it in that radical form. Just make sure your radical is off the bottom. Cosine, definition of cosine is x over r. So -2 over radical 13. Multiply radical 13 on top and bottom. So we get -2 radical 13 over 13. Tangent theta, tangent y over x. So -3 over -2 is a positive 3x. Which trig function is the reciprocal of sine? Cosecant. So that's r over y. Okay, let me ask you a question. Would you rather flip sine at the very end, or we could also go back and flip the one before we got the radical off the bottom? Yeah, don't make your life harder than it has to be. If you flip the one at the end, you're going to have to get the radical off the bottom again. We could go back and flip earlier, or just using this definition, radical 13 over -3, so negative. Negative radical 13 over 3. Definition of, or reciprocal of cosine is secant, so that's r over x, so radical 13 over 2. And reciprocal tangent is cotangent, so that's our x over y, positive 2 thirds. Yes, it should. Thank you. I dropped my negative on my 2. You guys ready to try one on your own? Here's your fraction. So if this inequality was about y, I would pick a y value first. It's telling me my x has to be a positive, so what did you guys pick for your x? 2. If you tried 1, you ended up with a fraction for your y, and I'm assuming that's why you went back and changed it to a 2. So then if you plug that in, you get y to be -1. So now find r. 2 squared plus -1 squared equals r squared. So r squared is 5, so r is radical 5. Okay, so sine theta, tell me what's the definition of sine? So we get -1 over radical 5, multiply radical 5 on top and bottom, so negative radical 5 over 5. Cosine is x over r, so 2 over radical 5 or 2 radical 5 over 5. Tangent, y over x, so -1/2. Reciprocal of sine is cosecant, so r over y. I wouldn't recommend flipping at the end. I would either go back to the originals or just flip right here. You get negative radical 5 over 1, which you could just tell me is negative radical 5. Secant, r over x, so radical 5 over 2. And cotangent, x over y, so 2 over -1 or -2. Any issues with those? Let's do one more and then I'm probably done for today. I'm going to do this one next. Why don't you guys try this one? So this is one where you couldn't draw a triangle if you did graph it. 0, -5 is right here. There is no way you could draw that for angle theta. So that's why we have to have x, y, and r. So our x is 0, y -5 if you do your r. And you get r to equal +5. So sine y over r, so -5 over 5 and -1. Cosine x over r, 0 over 5 is 0. Tangent y over x, -5 divided by 0. What is that? Can you divide by 0? No. A lot of times we write undefined. You can put the no solution symbol, that's okay. I'm just typically going to write the words undefined. A notation, they mean the same thing. Okay, reciprocal of sine is cosecant, so r over y, or just the reciprocal of -1 is -1. Secant, r over x gives you 5 over 0, which is undefined. Reciprocal of 0 is undefined. What's the reciprocal of undefined going to be? 0. If you do your cotangent, your x over y, you get 0 over -5, which is 0. So if it lands on an x or y axis, you are going to come up with a lot of zeros and undefineds for your trig functions. We are going to talk more about those values tomorrow. Those are some special values that will show up a lot, but I'm going to save that for then. So we are done, and you guys have a lot of time to work yet again. We are on the day 1 assignment here.